know the 5-number summary quickly and easily is always least to greatest. Laura, 1,000 points right there. And let's do this.
I found him. What's he doing? I don't know.
The 5-number summary is the following values.
He's talking to someone.
From least to greatest, min, Q1, median, Q3, and the max. Nice answers. If you put the 5-number summary in the chat, you get 1,000 points. Keep these answers coming.
What is it? What happened?
Hey, what's up, everybody? Welcome to the Kahoot tonight. How's everyone doing in the chat? I see Hannah here. 2 Hannahs here. Caroline, Andrew, Harry, good to see you. Who else we got? There we go. We got a few people watching. Say hey in the chat. Zoe, good to see you. Mubot is here. Let's give out some points. We got the music playing in the background. Turn it down just a tiny bit. There we go. Good volume for the music. Good to see you. Kamira, good. If I get your name wrong, please tell me. Robbie, good to see you. Everyone's here. We got a bunch of people hanging out. Let's put up on the screen right here the name of the game. There's the code right there in the background. Nathan, good to see you. Kendall, good to see you. Emmy, good to see you. Philip, good to see you. We're playing tonight for $20 first prize, $10 second prize. You never know who's going to win. We need to give out another 50 points. Let's throw out another 50 right there. Hannah, excellent to see you. How is everyone tonight? Everyone doing well? Studying up for the test? Oh my gosh, the test. If you didn't know, let's show where the review material is for the test. So be joining into the code right now in the background. There's the code. If you have questions about joining, let me know. Oh, I can do this. Watch this. The review for test 1 is right here. Mubot's going to help out. If you don't know who Mubot is,
I am Mubot.
He's our bot that gives out points right there. Your points should get added on. So everyone's points should start adding on right here. I think people's points are adding on. Check your points just here in a moment, Nathan, and also Alexis. Might just take a moment right there. Sorry. Headphones and everything going crazy. Ansling, good to see you. Doing well. Good to see you. Got a bunch of people joining in here. I'll vanish so you can see who's all joining in. Doing well, didn't realize summer second session starts the day after this one ends. Yep. We're almost halfway done. Next week's the halfway point, and we'll have the project. Andrew's got an amazing amount of points. Hannah's like, Ansling, good to see you. Pokemon Spotlight Hour. Swine up. No Pokemon for me right now. We'll wait another 2 minutes, and we'll get started on the game here. 2-minute timer initiated. Bro, I'm going to test my stats 1 knowledge. Ivan, so good to see you. Ivan from 320. Test your 201 knowledge. Join into the game. We've got Dandy Tiger, Decisive Stork, Lovely Impala, Creative Elk, Polite Hen, Amiable Wildcat. I love it when people are happy to see each other in the chat. They're like, hey, it's good to see you. Well, you always know who's here. Mubot is here.
Hello, Stat 201. I don't know.
Hey, everyone. Welcome to...
Maybe that's cringe.
I'm just going away. It's not doing it anymore. Not doing it. Who knows who that long-haired dude is in the background? What was he doing? I don't know. I'm clicking too many buttons. I made this during the deep freeze we had here in Texas when we had snowvid, when it got all snowy. And yeah, we're about to start here in about 30 seconds. Be joining in. No, 54 seconds. I'm looking at the timer right now. Be joining in. 53 seconds till Kahoot time. Puppet Shark, you ready for this, man? Man, you're always ready for everything, Puppet Shark. We're having some fun reviewing. Please ask questions while we're reviewing. So someone's going to win the Kahoot. Someone's going to come in second. But hopefully a bunch of people learn knowledge. Tiny Puppet Shark, you ready? No, Tiny Puppet Shark wasn't ready. There's Tiny Puppet Shark over there. Probably can't hear him through the music. 19, can we get 20? 20 people. We've got a 320 student. Maybe Andrew's playing along. Time's almost up. Be joining in. Where's the timer at? Timer says 18 seconds. Crab Rave. Oh, we haven't done that in a while. I haven't done the Crab Rave in a while. There we go. A little Crab Rave for everybody here. And the timer is about to start right here. You're playing, Andrew, with 22 people in. Here we go. I'm in the future, remember, so we're on like a 3-second delay. So be ready here. We're playing in 5, 4, 3, 2, 1, 0. Here we go. Let's Kahoot. Let's do this. Okay, so I might disappear sometimes. Let's test our knowledge. Question 1 says, which of the following phrases helps us identify quantitative variables? So whenever you're doing a quantitative variable, what are you asking? What is a quantitative variable? It's an actual real numeric number. So when you think quantitative, think quantity. So that's the key part of quantitative is quantity. So if you have something that is a number, it can be a quantity. Things like, if I say male is 0, then that's not a quantity. That's just a group using a number for male right there. So watch out. Sometimes we can do numbers for things that are not quantities. How much? Great job, everybody. Just awesome job right there. That's really excellent. So how much is quantity? So like how many apples did you buy? How much did those apples cost? How far was the store away? Kind of like an amount. It needs to be an actual real number representing real like amounts. The way to test if something is quantitative is to ask yourself, can I do mathematics on this? Like if you ask people, what state are you from? And you list them 1 to 50 in alphabetical order, that would not be quantitative because it's not how much is your state. We're asking, what is your state? Now, if you ask which one, who knows what that kind of sounds like? Let's throw some 20 points in the chat. If we can figure out like which one, if we're identifying something and we're saying like, which one is this? And it's in its own group by itself. What kind of variable is that? Which is a special case categorical variable. This goes all the way back to the beginning knowledge right here. Does anyone know if we say, it is categorical, identifier right there. Great job, Robbie, Hannah, and Caroline. Well, it'll be identifier, a special case categorical that is only a group of one is an identifier. So it identifies which group. Basically, Emmy, great job right there. And it is categorical, specifically an identifier if it's like which specific one. And those are categorical variables that have only unique values for each one. They will not ever repeat. Let's see who's in the lead. Oh my gosh. Glowing zebra. Why is there no bunny on the list? Maybe, I don't know if we have any bunnies today, but everyone knows big fan of bunny. We're getting a second bunny. It looks like, oof, a little rough around the edges. Ivan, you got this, man. You got this. Don't worry. Let's practice up. You ready? Good practice right here, Ivan. Show them what's up. Show them some 320 right here. My ear went out, but I am back. Hannah, we're glad to have you back. Second question. The University of Tennessee uses student ID number to track you in databases. What kind of variable is this? So they're using student ID number. So I don't think it uses student number. It's an ID number. That's a hint right there. So if we're using a student ID number to track you, then what would that ID number be used for? Is it like how much is your ID? Or like which group of IDs do you belong to? I don't think you're like, you wouldn't say to someone, oh, there we go. Excellent job. Now, one way people might get tricked right here is it's a number. It's a number, but it does not represent a what? So student ID number is a number, but it does not represent of student ID. So it does not represent a this of student ID. Like it's not like, use the word right there. It's not a this of student ID. So student ID number is not a this of how much your student ID is. It doesn't represent this. What are we trying to make sure people see right here with this concept? Even though that is a number, you'd be like, well, Brian, that is a number. You'd be like, well, it's not a quantity. Great. You see, Ivan, look at that right there. Ivan earned some 20 points for the chat right there. So Ivan is correct. It's not how much is your student ID. It's more about which student ID are you. Great job, Emmy, right there. Awesome work. We're going to identify which student this is by asking, what is your student ID? And it's a categorical variable that is unique for each and every student. Who is in the lead now? Glowing Zebra just going awesome here. Just Glowing Zebra, Zany Wolf. You know what? I'm voting on Zany Wolf or Dandy Tiger. Zany Wolf versus Dandy Tiger. Let's make it happen. Here we go. Which of the following phrases helps identify identifier variables? Now, this is kind of key to the concept of identifier variables. And I think this is the hard one people get confused on. Remember we did it earlier. There's a review question now. I throw in some hints. I like to throw in little hints to make sure you catch it. So if you're following along with what I'm saying, you'll get some hints. Remember, identifiers are things that will not ever repeat. They can't stop. They won't stop not repeating. So identifiers will not ever repeat. So when you ask an identifier, you're asking, which one is this over there on the side? Which one? So what group sounds more like a what variable? I always like, if there's a slight wrong answer, I want to point to what it is. What group points to a what kind of variable? Like if I say, what group do you belong to? Like we're asking, what state are you from? And I say, well, which group are you? Like, oh, I was born in New York. I'm not wearing my New York shirt today. But if someone says, you know, which group do you belong to for state you were born in, which I guess then some people might not be born in a state, like my dad wasn't born in a state. Categorical, nice job right there, TH. Excellent work. So categorical, I can't spell either. 20 points for not spelling. As long as you communicate the message, you've achieved your goal. And I did not spell properly right there. See, look at that. I missed a space. And now we got to redo the points. Remember, these points can be added on to your other points. I'll be checking through at the end of the semester to see what points you have. So keep earning those points. Swing by office hours anytime you see me live. Just hop on in, ask questions. Like if someone was on here right now and like, Brian, I need help on the 320 homework, I'd say, maybe afterwards. We're doing a review right now. So, oh, it did work maybe. Well, there we go. Nope, maybe it didn't work. Ivan's got a lot of points right there. Awesome work. Was that Ivan's points? No, I checked my points by accident. Okay. Who's in the lead right now? Glowing Zebra. My gosh, but Fast Cheetah galloping up to the lead right here. Let's find out the next question. Who's going to win? Which of the following graphics can be used for univariate categorical data? So univariate means one variable. When you see univariate, think one variable. Bivariate would mean two variables. I'll show the cheat screen here in a second. Let me get it ready to go. Okay, cheat screen's ready to go when we see this. But which of the following can be used for univariate categorical? Now, some of these are univariate quantitative. I might have said this. I say it during my lectures. I probably say it during a speed run. But there's two of these that go together. And I think Ivan took two with me, so you might remember. Oh, no! Can anyone explain what's going on right here? I have a favorite saying. Didn't see the categorical. Oh, no. Categorical is a what kind of question? Like, what's your favorite pie? That'd be categorical. And I'd say Oreo pie. Gosh, I'd love some Oreo pie right now. Or what's your favorite bar? And I'd say Barcade, the one where you can play all the video games. Because, I mean, come on, video games. So a categorical question would be like, what's your favorite pie? Apple pie, pumpkin pie. It puts categories out there. Categorical question could be like, what's your favorite bar? Does anyone notice the association I'm making right here when I say, what's your favorite bar? What's your favorite pie? And it's almost like these questions. Do you see it? When I say, what's your favorite bar? What's your favorite pie? You can make a pie chart of your favorite bars, and you can make a bar chart of your favorite pies. Totally stealing this from How I Met Your Mothers. Thank you, Marshall Erickson. But you can make a pie chart of your favorite bars, and you can make a bar chart of your favorite pies. Does that make sense to everybody? If you say to someone like, what's your favorite pie? They could say apple pie, and then you could, that's a category of people who like apple pie. If you say, what's your favorite bar? Someone might say like Half Barrel, which is a bar in Knoxville, those don't know. And then you could make a bar chart or pie chart, either which or, of people's favorite bars. So the good note to take on this is you can make a bar chart of people's favorite pies, and you're just asking, what's your favorite pie? That's one question. Univariate, peach pie, awesome stuff right there. Throw a little cinnamon in that, make it really good. Cinnamon nutmeg maybe? I don't know. I don't know what you put in a peach pie. Univariate, meaning one question, one variable has been asked, and we are seeing a pie chart of your favorite bars and a bar chart of your favorite pies. Now, a box plot and a histogram are slightly different. A box plot and a histogram, for histograms and box plot, we need what kind of data? Who knows? And let me show the cheat sheet up here, and I'll disappear. But we need what kind of data for, and I can't, unfortunately, hover over this, but we need what kind of data for histograms and box plots. Look where they're at. Quantitative. Great job, TH. Excellent work. So histograms and box plots, also stem and leaf plots and dot plots are quantitative. Everything blue right here is quantitative, but there is bivariate quantitative like scatter plots and time plots, hints for later on. And then everything in green is only categorical. So you see down here where I'm at, I'm over here in this corner, I'm in the bivariate categorical section where you have mosaic plots, contingency tables, stacked bar charts, side-by-side pie charts. These are bivariate categorical right where I'm at. But then way up there at the top is the univariate categorical with bar charts, pie charts. We got the connection between them. Pareto charts, which is a bar chart put in order. Frequency table, which is just the counts of each thing in each group. And a ring chart, which nobody likes ring charts. There are some bivariate combinations that have a categorical Y and quantitative X, or vice versa, and those are seen in these associated boxes right here, like side-by-side box plots, and also stacked histograms, and logistic regression, which we cover in 320. I would take a screenshot of this. It's a decent graphic to know, at least when knowing which types of variables go with certain types of displays, and understanding the quantitative categorical distinction. So, and you can always pause the video. Ring chart, yeah, some people like ring charts. Me, not so much. What kind of data? categorical data there that you can use a ring chart. Glowing zebra, making it happen. Is it Andrew? Who knows? Who knows who it is? Let's find out with the next question. Who's going to win? Here we go. Great job, Harry. Which of the following graphics can be used for bivariate categorical data? So if you took that down, you should see bivariate categorical. And you probably have heard me say QQ straight enough, no outliers. This is not some QQ straight enough, no outliers right here. Not two quantitatives. Bivariate categorical. Great job, Harry, right there. Bivariate categorical. Let's just show that really quick. There's the cheat sheet. Pins on the bottom right behind me. If you look where I'm at, it's right behind me. 2145280. Sorry about that, Emmy, right there. Oh, what happened right here? A scatter plot. What is a scatter plot for? So who knows what a scatter plot is for? So if we have a scatter plot, what are we drawing? Quantitative relationships. Exactly. So in this instance, both of these variables are quantitative, but in Mosaic, like if you compare people's heights and weights and you look at as someone's height increases, what we would expect for someone's weight to increase. Who knows what we call this? Let's throw some 50 points if you can. Now, my class 320 should know this, and you'll know it too. You covered it in chapter 7. When you have two quantitative variables and you fit a line to it, what are we doing here? You could also look at kind of the ellipse of this and see the relationship there, which is another concept we cover in chapter 6. But fitting the line is, and you'll write an equation for that. That's known as what? Regression line. Zoe, great job. Line of best fit, regression. Chimera, excellent work. Great job. I'm excited to see the scores. Keep working on this. Keep reviewing. And the review videos are posted. Mubot in the chat right now is going to post you the link for the review. If you haven't seen it, please be checking that out. And always swing by anytime to ask questions. I know this is an asynchronous class, so I could just be like, I could just post everything and say, hey, go watch it. But we're here for help. I don't want to do that. I want to be like, hey, go watch it. We're here for help. If you're stuck on questions, let me know. Email me, bstevens@gtk.edu. I'll drop that in the chat right here real quick so you can see. And just email me whenever you're stuck. The material's going to get slower. We're going to do less chapters, but it is going to be a little more difficult. So it's going to slow down in speed, but it's going to get a little more difficult. The mosaic plots right here. Let's draw a mosaic plot so we can see it. One of my favorite mosaic plots to talk about is the following mosaic plot. And how do you know if there's an association? So we got right here mosaic plot 1 and mosaic plot 2. Now let's look at whether or not somebody passes a test. And how would you feel about this? Okay, let's put this. Oh, really? So green is passing the test and red is failing the test. So let's say you have the choice between test A and test B, and here is pass and here is fail. You have the choice between test A and test B, and here is pass and here is fail. So both of these, test A and test B and pass fail, are what kind of questions? Like when we talk about test A versus test B and pass versus fail, both of these are what kind of question? Andrew's taking his chances with A on that. Like if I say you can take test A or test B, and you will either pass or fail these tests. Both of these are what kind of data points we are collecting. Test B on both. Ignore this graphic for a moment. Ignore that graphic over there. Just saying. Wait, can I zoom in so you... So only looking at what kind of variables are these? What kind of variables? Because we have a mosaic plot, categorical, Lexus, excellent work right there. They're both categorical variables making the mosaic plot. And we can do a contingency table, which would just show the counts. Like we could find out in the contingency table for this group, if you're wondering what a contingency table is, we could have here people who took test A, people who took test B, people who pass, people who fail. And then you could see the amount. Like test A had 4 people pass and 10 people fail, where test B had 6 people fail and 20 people pass, something like that. And we could do the totals on the sides. Contingency table is just going to show you the counts of the observations. So you can see right here, these are the people who failed who took test B. So those are the 6 people. It might not be relative to the size perfectly right now, since I'm just doing a sketch right here. But how do you know that there's an association in this mosaic plot? How do you know that there's an association? And people were saying, I want test B. Andrew was going out on a limb, going for some test A. When you look at this, we can look at what is called the conditional distribution. The conditional distribution is this right here. Given somebody took test B, they have a higher probability of passing. Given somebody took test A, they have a higher probability of failing. So you're really kind of looking at this distance right here between the two conditional distributions, comparing individuals who took test A versus individuals who took test B. But what do you notice over here in the following graphic, which I'm highlighting now? What would you say between test A and test B in that graphic? So in graphic number 2, it looks like there is or is not an association. So you look here, given somebody took test A, here's their pass-fail rate. Given somebody took test B, here's their pass-fail rate. And what do you notice about the two when you look at the pass-fail rate here on this right here? And why would you be like, it doesn't look to me like there's much of an association right there? Why would you say that? There's not an association, and why? Oh my gosh. Things going crazy. I'll just go tiny, Brian.
Why is there not an association?
There's not an association because the conditional distribution, people who took test A had the same pass rate as those who took test B. Now, I would like to say also, it doesn't have to be identical. We'll especially be going into this in one of the last chapters on the test. Usually we want to see if there's a big difference or a small one. One is that likely by random chance, and probably small differences like this would be likely by random chance. Tiny Brian's always back. Colin, excellent work, and so proud of you with Disney and everything. So good to see you here, Colin. Excellent work. Colin, they don't even know about quotes and everything. Colin's got a few favorite quotes. Andrew's got a few favorite quotes. Throw those quotes out there and make it happen. Let's see who's in the lead. Ooh, Zebra's down. Zebra's down. No, Great Turtle in the lead. Great Turtle in the lead. Let's find out who's going to win with the next question. Here we go. Mubot knows. That was our random quote. Find the IQR of the distribution. Oh, that's a small picture. Can I do the zoom? Oh, I can see it. Can you? Let me zoom in on this. I think they changed how that looked. Find the IQR of that distribution. Looking at it. I think they changed how pictures work. You can see it if you look carefully. I swear they changed how pictures work. I'm a little bit worried right now. What? Great job, those who got it. What is the IQR? My gosh, what are you doing to me, Kahoot? What is the IQR of a box? What is the What is the IQR of a box plot? How is it representative? What is the IQR of the box plot? Where is the IQR on this screen? Like, where do you see the IQR in here? Where is it represented? What is the IQR of the box plot, and what is it? Sometimes we get a little extra. That's the median right there, that line. That's the mean. You don't usually see that in a box plot. Sometimes they graph that for you. But what is the IQR of the box plot? The IQR of the box plot is the what? The pin should be behind me. I'll make sure we show this right here. The pin is behind me right here. And what is the IQR of the box plot? It's right down here in the bottom. It is the interquartile range. But what is it? Like, visually, what is it? Visually, what is the IQR? It's the range of the middle 50% of the data. Perfect answer. Hannah right there. Let's throw some 20 points. It is and then visually, what is it on there? It is the range of the middle 50%. It is the box. It is the box right there. You see how it starts here at 0 and goes here to 2? Can anyone tell me? And the median is right here. It doesn't have to be in the middle. Sometimes the median can overlap. Can anyone tell me what the minimum value is? And think we asked people, how many pets do you own? So what was the minimum value reported? The minimum value reported for number of pets owned. Great job. Mary's put the answer in the chat for how to solve it. Great job, Mary. Throw another 20 points. What was the minimum value? 0. And then what does this represent right here? So this is 0. This is also the 25th percentile. This is the 50th percentile. And then right here is the what percentile? This right here where 2 is at is the what percentile. It's Q3. Great job there, TH, which is the 75th percentile. Great job, Caroline and TH. Excellent work. And then this is where people usually get confused. You notice right here, this is 1.5 IQRs above Q3. This is a length of 2, right? Well, we go up 1 IQR, which is 4, because you're going up 2, and then a half. 1.5 IQRs above Q3 is where the fence is at. Sometimes the whisker goes to there. This is where outliers begin, and these are people who have an unusually high amount of pets. It's not working. I don't know why. Sorry for this. No worries. Let me make sure I got the code right there. Let me look at the code. 2145280. Oh, I put in a wrong number. There we go. There it is. Great. Thank you so much. Thank you, Colin, right there so much. And so does everyone see how we found the IQR on this? Does that make sense? I'm sorry, the picture's a little bit small. I swear it was bigger. And what is the range of this data? Who can calculate the range of this data? This is an answer people usually get wrong, and maybe there's a question coming up that you might want to watch out for. Who can calculate the range on this data? Who knows what the range of this is? Q3 is the 70. Yep, that's where Q3 is at. And think about it, 3/4. Think about if you have 3/4, and great job on the range of the data. It is 8. Does that make sense right here, Hannah? That Q3 is the 3rd quarter. It's the top of the box plot. And so the range would go all the way across here. It's going from the lowest to the highest, max to the min, or max minus min. Harry, great answer right there. Harry's showing the mathematics. Max minus min, 8 minus 0, and that is the range of the full data set. Excellent work. Andrew trying to trick us right there. Here we go. Who's in the lead? I don't know. Smart Bison just jumping up right there, right on the back of Great Turtle. Let's find out. Bison versus Turtle. Yeah, no, excellent work. When you think of Q3, just think of 3/4. Be like Q3, so you just got 3/4. So if you have 3/4, then you've got 75 cents. Q3, I have 3/4 of the data. So good way to remember it right there. Keep asking those questions. The group of individuals or things we want to understand is the what. Ooh, this will come up way important later on. What is the thing we want to understand? The group of individuals or things we want to understand is the what. Now we collect data on something else. We collect data on a sample, and samples give us statistics. Well, the sample, really quick answers right there. The sample is what we collect data on to get insight. Like let's say you're going to throw a party. You want to understand what toppings people want for their pizza. So what might you do? You might call up 3 of your friends and say, hey, what kind of pizza do you want? And the 3 friends you call up would be your what. Your 3 friends you speak to, because you're going to throw a party for like 20 of your friends and say, hey, what pizza toppings do you think we should get? And hopefully your 3 friends are representative of all your other friends. That's going to be your sample right there. So your sample, really small sample, because you're not throwing a big party. Your 3 friends are going to be your sample, and they're going to give you insight into what to do for the party, which is the population. Oh, it's all pineapple. We're doing pineapple and onions, pineapple and sausage, pineapple and mushrooms, pineapple plus everything. Awesome pizza. Sorry, Andrew. Pineapple plus pineapple and ham is really good. Pineapple ham thin crust, awesome. Unless you only have, see, Camaro right there is all just, man. Pineapple ham thin crust. Ivan, you got to have some good mushrooms, no fungus on my pizza. We're about to start the real controversy right here talking about pizza. So one thing I want you to remember is I want you to write down SSPP. This is going to come into use for future. What do you think is going together? I resend my RSVP to this party. I rescind it. What do you think SSPP stands for? This gives us insight into this. Because you're going to talk to your small group of friends, like a small group of friends. That's going to be your sample. They're going to give you a statistic, like maybe they're going to give you like all 3 of them say you need pepperoni pizza. Well, that's an understanding that everyone wants pepperoni pizza from that small sample. Or maybe you're throwing a big block party and you talk to 20 people. Now you got a bigger sample and you ask like who eats pepperoni, and you say, well, out of these 20 people, everyone eats pepperoni. I know that people don't eat pepperoni, but it's pretty much one of the most popular pizza choices. So we have Andrew's helping out right there. So they're going to give us a sample statistic, and that gives us insight into the population parameter. So when you think about what a population parameter is, the population is everyone. Great job, Harry, right there, and Andrew. The population is everyone you want to understand. If you're throwing a block party, you want to understand all the people who are going to come to your block party. And then the percent of them that would eat pizza. No, that's exactly right there. Population parameter. Oh, sample statistic population parameter. And so the percent of people in your sample who would eat pepperoni is a what? So follow me on this. The percent of people in your sample of friends you speak to who would eat pepperoni is a what? So the percent of people who would eat pepperoni in your sample, like if you talk to 20 people and 95% of them say they would eat pepperoni, that, because that's a sample, that would be a what? This is a key thing a lot of people don't know later on. If you talk to 20 people and 95% of them would eat pepperoni and that's your sample, that 95% would be a what? The 95%, when you talk about that, that is a what now? Tough question, right? So think of a statistic. That's a statistic because it came from a sample. But when you throw the block party, that's the whole, so it would be a statistic. It'd be like a sample statistic, like from our sample, we have a statistic that 95% of people would eat the pepperoni on the pizza. But when you throw the party for the block party with maybe like 300 people there, that's the population you were interested in. And then maybe 93% of them eat the pepperoni. Like you have them fill out like a comment card at the end. You say, hey, if everyone can fill out a comment card, and everyone does, you get a census of the population. When you find out 93% of the population eats pizza, the 93% of the population eating pizza would be known as a what for the population. Like for your whole population, this is the true value that 93% of them actually eat pizza. You estimated it to be 95% from your sample statistic because you talk to a sample group, they give you an estimate, which is a statistic. And so the 93%, which is the truth for the population, would be known as a what? So when 93% of the people who come to your block party eat the pepperoni pizza, then that 93% would be a what that you were trying to estimate before. You were trying to be like, well, what percent of people are going to eat pepperoni? So the truth that we're trying to estimate, that's the parameter. Does that make, this is what you're interested in. You want to know, and that's the actual data. So actually the parameter is the actual, Hannah right there, I really like that. That's the actual data. And the sample statistic is what we would use to make a what. So the sample statistic is the prediction because it's an estimate of the truth from a sample. And so Hannah, you're right there. That is accurate wording to use, just slightly different way of speaking about it. And then the parameter is the actual truth that you were trying to understand. Does that make sense right there as we clarify what a population is and the parameter is the characteristic you want to understand, and our way of understanding that will be from a statistic. That is the estimate of the truth, which is the parameter we want to understand. Sometimes these words get a little bit confusing. I've heard them 1,000 times, so my brain's used to them, but hopefully these examples help out. Let's find out who's in the lead though. Oh my gosh, great turtle. Let's do a little puppet shark for that. Great job right there. Great turtle. Let's find out who's going to lead with the next question. Which variable is a special case categorical variable? Review question. 20 seconds on the clock. Got to be real quick. Which of these is a special case categorical variable? Not saying this can appear on the test, but it can. This is one of those questions that definitely appears on the test every once in a while. So which of these is a special case categorical variable? It stands for groups of ones, and these are identifiers. Now, we've got some other words on the screen here like continuous and discrete. So continuous and discrete, I was like, I miss teaching in person because I'll call Papa John's and I'll say, I want 3.2 pizzas. So Brian is using which one of these on the screen right now? Am I using a discrete variable? Am I using a nominal variable, an identifier, or a continuous variable to say I want 3.2 pizzas? So if you say to someone, I want 3.2 pizzas, or I have 3.2 bunnies, you'd be like, you have 3.2 bunnies? You have this amount of bunnies? Your variable is on a blank scale. So think about a scale that has anywhere you could mark. I do have that highlighted right now by accident. It's continuous. Continuous means it can take on non-whole numbers. Discrete, yep. So continuous means things like 3.2, 4.1. It can take on non-whole numbers. So both of these are what kind of variables? Quantitative. So discrete is when numbers are like 2, 3, 4, 5, 6, 7. And then what is nominal? Because that was the second highest guess. So what is a nominal variable? A nominal, look at the root of it, is no. And then what does the no mean? It has like no order to it. You either have a nominal categorical variable or an ordinal categorical variable. Let me re-say that. Nominal or ordinal. If I ask you, are you a freshman, sophomore, junior, or senior? Is that nominal or ordinal? So nominal or ordinal, does it have order to it? Like, are they categories that are in order, or do they have no order to them? And name would be nominal. And freshman, sophomore, junior, senior is a ordinal categorical variable because it goes in order from freshman, sophomore, junior, senior. And these are categorical types of variables. Another nominal variable would be like what state you're born in, or a different type of one because there's no order to what state you're born in. If I ask you favorite ice cream flavor, that would be nominal because there's no order to it. It's just like, I like cookie dough ice cream. Now I want cookie dough ice cream. So Nominal means it has no order to it. Just look at this right here versus an ordinal categorical variable. And so we have right here, good to see you, Nathan. We have right here an identifier is the special case categorical variable. The only other type of categorical variable is a nominal, but they're not super special. This is the special kind of categorical, and it gets its own kind of name. So let's check out who's in the lead. Oh my gosh, this is an insane leaderboard. I got ice cream. Oh, don't tell me that, Andrew. I'm trying to work out, man. I'm losing weight, trying to get healthy. You're gonna convince me to eat some ice cream sandwiches, man. I'm gonna go out and buy those this weekend. Time plots are a special case. This a time plot. This is a multivariate time plot. It's got 2 time series on it. I think I know what the best guess is going to be. Now, time plots are bivariate. So time plots are bivariate. They are this with on the time axis, and I swear they made my graphics smaller. Damn you, cahoots. Great job. Time plots are special case trying to read comments to it. And just cracking me up as I try to read as I try to answer questions and do the Kahoot. Don't worry, you can still feel free to crack me up. The only difference about a time plot is on the x-axis, it has time. So this is like a time index right here at time 1, at time 2, at time 3. And they're apparently doing it within these intervals. Like this is maybe minutes in. So they're plotting it over time. They have 2 different sequences right here. So this is a time plot over time for these 2 companies. Maybe it's like just at certain points throughout the year or different time intervals. But a time plot is a special case scatter plot. Scatter plots are bivariate quantitative. Scatter plots are bivariate quantitative. Time plots are bivariate quantitative. Just the x-axis is time, which is quantitative. Like how much time has passed is a quantity of time. So it's that specific thing. Great job right there, Alexis, about to reach the next level. Let's just throw out some 10 points for Alexis. And you should be at that next level. There we go. Mubot giving out those points. Great turtle back up there, though. Time is relative, though. Just snap away that time. Here we go with the next question. Let's do this. Which distribution has the biggest range? Watch out. Watch out. Look carefully. Look very carefully. Watch out. It's very easy if you notice something. I need someone in the chat to say that's something though. It's if you notice it. Oh no, I'm scared. Oh no. Did you see it? Oh no. Who sees it? Who sees it? Ivan said, oh my God. OMG. What is it? What do you see? Outliers. Kamira, excellent work. Oof. Yeah. Always include the outliers. The DWT. The DWT next to campus. Everyone says DWT with the AWT. Big boy outlier right down there. Alex is cracking up. So you got the big boy outlier down there. Just make sure you... On-campus outlier, yep. Someone with a 0 GPA, I mean, come on. I mean, I had like a 0.2 GPA, so if you can't get that 0.2 GPA, how do you have a 0 GPA? I don't know what's going on. So a little tricky right there. I see why a lot of people put the fort. The fort, I think, has one of the bigger ranges, but that DWT right there, my Newark accent with the DWT, definitely creates the biggest range right here. Always remember outliers is kind of one of the big things right here. Whenever you're doing the range, always look at the outliers. A lot of people forget them. Hence why I made up this trick question right here that just catches people all the time. So do not forget outliers when looking at the range. Like be taking your notes right now. Make sure to look at outliers when calculating the range of data. Here comes the shakeup of the leaderboard. Here we go. Did nothing happen? Okay. And then let's do the next question here and see what happens. Hopefully the game's still working. Next question. What is the best measure of center for the distribution? Here we go. Oh, I think no one got it right on the top of the leaderboard. Oh my God. I've never seen that. The center of the distribution. A little smaller graphic, but you should be able to tell the shape of the distribution pretty well. Shape, center, spread is how we describe univariate quantitative data. If you got that last question wrong, don't worry. Most people got it wrong. Take the note, though. Look for outliers when doing the range of a distribution. I was too slow to answer. That's perfectly fine. Don't worry. We're here to learn. And what is the shape of this distribution? What is the shape of this distribution? What is the shape of the distribution? What is the shape of this distribution right here? Who knows the shape of this distribution? Skewed to the right. Now, what are our two measures of center? When we have two measures of center here, we have the mean or the median. And so the mean is used when it's normally distributed. Great job there, Bailey, Pooja, and Nathan, and Kamara, and Hannah. TH, awesome work too. The median is used when it's skewed. What would be the proper measure of spread for this distribution? So the center is, and as Andrew points out, it's either going to be mean or median. Mean if it's normally distributed, and median if it's skewed. And then we have to choose between IQR and standard deviation. Interestingly enough, these are on the bottom right here. They're kind of paired together. And IQR and median are up here on the top. And great job, TH, right there. IQR is the measure of spread when we use median. And think about this. They're both based on percentiles. So, you're talking about the median, which is the 50th percentile, and the IQR, which is the distance between the 25th and the 75th. So it makes sense to me that these would be paired together. The median and the IQR would be paired together because they're percentile based, and the mean and standard deviation are paired together, interestingly enough, because the standard deviation is calculated by how far things are standardly deviate from the mean. So going on to the next question, let's find out. Leaderboards joining up again. Outliers impact standard deviation in a big way. Excellent job right there, Ivan. Great answer. Here we go. Brooke and Hannah, excellent work. Let's continue on. True or false? Outliers can make a strong correlation weak. Outliers can make the slope of a negative line positive. Ivan knows this 100%. So outliers can do anything pretty much. Almost. Got Superman right there. Anything is possible with outliers. Except for maybe something coming up here later. But outliers can make correlation weak. They can make it strong. So outliers make correlation weak, make correlation strong, make correlation positive, make correlation negative. Outliers can dramatically impact correlation. Exactly. Outliers can do a lot. But maybe there's something they can't do. Just saying. So great job. Leaderboard is really tight right now. I do not know who's going to win this. Remember, $20 first prize, Amazon. Email me. Make sure to email me. Maybe take a screenshot. I've never had multiple people email me and say, hey, I won. We'll handle that scenario if it ever occurs, but everyone's pretty much emailed when they've won. Email me. If you win, I'll make sure to remind you at the end. Here we go with the next question. True or false? Outliers can dramatically impact the IQR. Hint. Or median. Hint. Outlier kryptonite. That's the hint right there. If you know Superman. We got some outlier kryptonite right here. So outliers can dramatically impact the IQR median. That is false. You say, wait, Brian, outliers can do anything. Asterisk. Outliers can do really anything except impact the median. Let's go and IQR also, because they are based on the what of something. The median and IQR are based on, think about this. Like if I put everyone in a line right here and I say, Brian is right here at the salary of the company. So I'm going to pay Brian $50K a year. And I'm going to pay this person $1 million a year. And now we'll pay him $100,000 right now. You are going to get the median salary of this company. What amount of money are you going to get if you get the median salary at this company? Your company says, I'm giving you the median salary. Your company says, I'm giving you the median salary. Double check. 3 numbers right here. Put everyone on a balance beam. We got right here. We put the balance beam right there. There we go. 50K, no worries. 50K right there. You're making 50K. Well, guess what? Your boss says, we've been doing so well. I thought I could move the boss right there, but I can't. The boss says, we've been doing so well right here. The boss is just going to go and give themselves a raise. You've been doing such a great job for them. And the boss's salary is going to go over here. They're not making 1K anymore. They're making 1 million. And they say, you know what? we're going to be so nice. We're going to give you the median salary. How much money are you making right now if you get the median salary? Your boss is a big outlier over here making $1 million. So your boss says, I'm just going to go further away from you over here. Just go right over here, make my $1 million. And you say, okay, I got my median salary. How much money are you making? You are still making $50,000. Now the mean is going to go follow the boss. The mean is going to go over here, and the mean's usually a diamond in the box plot. The mean is going to go follow the boss and follow the skew of the data. You're still making $50,000 though, because the outliers will not impact the median. It doesn't matter where the boss is. You're still here at the 50th percentile because there's 3 observations. So there you are, and you do not change. Same thing works for IQR because IQR is positional based. So if there were more people in this data frame, the 75th percentile and the 25th percentile would not move based on an outlier on the high or low side. So outliers really can't impact these marks in the data. Like if you had a whole bunch of random people throughout here, then these random people are not going to get impacted by the one person moving. Maybe. Speaking of that Amazon gift card, the UK thing, and I don't know. Feel free. You're always free to, yeah. But like, I don't know. It's the easiest thing to, Alexis, if we were to change whatever gift card we gave out, what would you suggest? Because I mean, they are kind of ruling the world right now. So, I don't know. I don't know what people would suggest. I'm always open to suggestions. It was hard. One time I did like, Target. Maybe I should get some Target. You know, I should get some stuff on campus, especially Starbucks, Dogecoin, give out some Dogecoin. So, you know, we're not going to the moon yet. Always food. I do donuts and stuff for the semester and stuff. Andrew can tell you I brought some donuts to class, but with me being in Texas, Chick-fil-A, man, you guys are making me hungry right here. You know what I could do is when I go back to Knoxville, I could get some gift cards, put them in or I could get like little snack things like jelly beans that are in their own separate bag, like sealed and everything. So I could get some $20 gift cards from like Chick-fil-A. Maybe I could get some donations. Maybe we could get sponsored. Ooh, so maybe I'll start doing some talking to Chick-fil-A, Target, and say, hey, I stream to UTK students. If you want to donate to the channel, I've never had class with you, definitely in the office though. Yeah, exactly. Oh yeah. Yeah, well, did you ever get donuts when we were in office? I don't know. I hope you did. I bring donuts to class. Last day of class. Miss those days. Let's do this. Next question. What is Q3 for the data? Where's that Q3 at? $20 worth of jelly beans. Where's that Q3 at? You should be able to see it if you know where Q3 is at. I'm not saying the answer's on the screen right now, but I mean, I'm not blocking any answers you don't need, or you do need. Where's that Q3 at in the data? Q3, we talked about this data set a lot. We should know how to look at box plots. Q3 right here is the top of the box plot. It is right there at 2. They did make my graphics smaller. How dare they? Oh no, Alexis says no. No. Let's find out who's winning. It's a close lead. Close lead right here. $20 to Cool Beans. We're not going for jelly beans here. We're going to Cool Beans. Hey, if Cool Beans will give me $20, and I mean, I guess you can eat food at Cool Beans and stuff like that. And just as long as I'm not like, I don't know, like Ash's Wines and Spirits. They're a great place as long as you're 21. So, yeah, I'm not going to go to them for. If people are giving me $20 gift cards to give out on the YouTube channel, I'll tell them. I'll say like, hey, I run Kahoots that are broadcast to about 100 students sometimes. Varies on what class I'm doing. So yeah, let's try to get some sponsorship. Here we go. Let's find out next question. What is the equation for a residual? Lots going on the screen right now. This is what you should remember from the slides right here, talking about residuals. We're going in some chapter 7 right now. There's a lot to read. Now remember, we want to think about like some sort of music right here. Singo night at Cool Beans. Bingo with songs. That sounds fun. That sounds fun. Shout outs to Cool Beans right there. If you're in the over 21 crowd, check it out. Or 21 and older crowd. When you think about residual, did I put 2 right answers here? Oops. How did I do that? It's actually this one. So some people got some free points right there. So residuals, exactly. Residual equals actual minus predicted. So when you look at the residual right here, the actual is the blue point down here. This is the dot. And then the predicted is up here. So the residual being negative means what? The actual was what to the predicted? If a residual is negative, then the actual is what to the predicted. If the residual is negative, so think this is a negative residual. This point down here has a negative residual. If it is negative, then the actual, which is down here, this is where the point is at, is what to the predicted line by being negative, which is what you see on the screen right here, like the blue dot. It is lower than. So the actual point is lower than what it's predicted to be by 14.6 right here. Spending hours on the quiz, maybe not forget. Yes, TH right there. You're going to note for the test. And then where would something with a residual of 0 be at? Something with a residual of 0 would be where? Bro, Ivan in here trying to take these points from 201. Trace jumping on. Good to see you, Trace. So where would something with a residual of 0 be at? On the line. That means we didn't miss. Think about a residual being like what's left over. Do you see this point right here? That's a big residual right there, which is how far things are away. So exactly, Gavin, those bonus points. So you can see things with small residuals are very close to the line. Negative residuals are going to be below the line. Positive residuals are above the line. You can make a residual plot by making everything flat. And notice how TH said, going through, working those assignments really helps get it down. It's a lot of practice right here. So I'd be reviewing. Make sure we're going to drop that review link in the chat again. Review 1 chat. Review 1 link is in the chat. So it's got all the videos, got the playlist. It's to get that 25,000. Yeah, do it. Do it up. So we see here, great turtle. It's going to be a close game. Close game. Let's find out who's going to win with the next question. Quiz question here. What percent of track runners are expected to run at a time of 290 or higher? Oh my gosh. 290 is at a z-score of -2. 290 is at a z-score of -2. So we want 290 or higher. 290 is at a z-score of -2. They shrunk my graphics. I'm very sorry. 290 is at a z-score of -2. That's where 290 is at. If you know your 68, 95, 99.7 rule well enough, -2 is the answer for the z-score on this. And we want 290 or higher. So you can visually see right here. I'm sorry they shrunk the graphics. I swear these were bigger last time I looked at them. They really did not help me. I will have to be fixing this. Thank you, Kahoot. Oh, you're a free service. You do well, Kahoot. So 290 is down here. What does it mean that it's at a z-score of -2? What does it mean? Like interpret the z-score, which is chapter 5. What does it mean that it has a z-score of -2? Two standard, Alexis, great job right there. 2 standard deviations below the mean. Now, how can I use this to my advantage? I need to know the numbers that are 68, 95, 99.7. So knowing those numbers right here, I can go in and graph that the middle 95% is between here and here. If 95% is inside, what is total outside? 95% inside, what is total outside? So be very careful. I'm not asking one hand yet, but what is total outside? If 95% is inside, what is total outside? 5% Pooja, great work. So then we're going to cut this in half right now. So 5% total, 2.5, and technically 2.5 over here, but how did we get our answer of 97.5? We're going to start right here and just follow it all the way over, which means we need to calculate all the areas across these because we're technically traveling across that. So what do we get when we add this up right here? 97.5 total. Does that make sense? Or you could just say 2.5 minus 100, because this is the area we don't care about, and the remaining above it would be the 97.5. So you could subtract from 100 to get the remainder. Does that make sense? Great work right here. Really good practice. Kind of a tougher. A lot of people say, well, in Chimera, great job. A lot of people say, well, how could we do this on the test? Canvas content has great practice questions. Also, this one right here is just a short kind of practice question. Great job. 68, 95, 99.7. I've done these numbers way too much. And if you're wanting practice, you can always look at the David M. Lane applet. Lots of good practice there too. What's up, our random people? Going on, we'll try to zoom in on graphics if it happens. Glowing zebra, 6 questions in a row. Let's find out who's going to win. What percent of area on the graphic is shaded according to the empirical rule? Oh, this is a trick one. Oh, you got this though. You got this. We just did a question very similar to this. You can see this is between 0 and 2. We just did between -2 and 2. So remember, we did between -2 and 2 is 95%. So what area is shaded on the curve right here? What area is shaded on the curve right there according to the empirical, which is the 68, 95, Andrew put in the chat, 99.7. Who knew how to get this? I bet some people got it. How did you get the answer to this question? How did you get the answer to this question? How did you solve it? Who solved it and how did they do it? So let's draw on this. There we go. Andrew's showing it right there. 95 divided by 2. Does that make sense? 95% is between -2 and 2. And we're just taking it and dividing it in half right there. Great job, Camara. Also, awesome work. So you could get this right here. How much area? Here's a tougher question. Who knows? Let's throw out some bonus points for this too. Who knows how much area is shaded on the curve now? Who knows how much area? Know that. Exactly. Hannah, great job. Hannah's actually giving away the answer to the next one. Let's throw out some points. Hannah, I think you'll be able to figure out this one really quickly because I think I showed this. We'll throw some 50 points. Why not? So can you figure out this? 81.5 exactly, because Hannah actually just said in the chat that this is 34, which is half of 68. So Hannah said, well, this is 34, this is 34, this is 13.5. And this should be in the notes. We've got the graphics right here. If you add that up, you get 81.5 area. So, and you could also subtract, if you think that this is 13.5, you could do 95 minus 13.5. So that's another alternative solve right there. Quite a few ways to solve this, just really good practice. So know your empirical rule. Great job, Hannah. Looks like you know those numbers extremely well since you know the 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, 0.15. Make sure to check out the notes and practice up. Great work. Fast Cheetah's back. Who's going to win? Here we go. A test has a normal distribution with a mean of 75 and a standard deviation of 5. What percent of students make above a 70? What percent of students make above a 70? So you need to figure out the z-score for this pretty quickly. You know that the mean is 75. Who can put in the chat what the z-score for a 70 is? What is the z-score for 70? You know the mean of the test is 75. The standard deviation of the test is 5. So what is the z-score for 70? So what would the z-score for a 70 be? -1. Great job, Alexis and Andrew. Because they're one standard deviation below the mean. So they're being one standard deviation below the mean, because they're below the mean, make sure it's negative. So area from, and it'll be from -1 to infinity. So area from -1 to infinity. So just above completely. Oh, no worries, Pooja, no worries. Just practice right here. This is where we get questions wrong today so we can get them right tomorrow. We practice up. Z-scores can be positive or negative, and they tell us if something's above or below the mean. So I think Hannah and everyone's going to get this pretty quickly. I just really am glad someone put the numbers in the down. I'm like, yes, you know it. Great job. Excellent work right there, here, everyone. We got more right than wrong. I'll take it. I'll take it. To infinity and beyond. Man, it's funny to think I watched that in high school. You're like, I was watching that when I was a kid. Or that came out before many people were born. Haha, I'm getting old. So we go right here. And we got 75. And we got 70. Which this is a z-score of 0 and a z-score of -1. And then how do we find out this answer? Well, if you go between here and here, you'd have 68. Which makes this 34. But the easy thing to do then is just go from here over. How much is above a z-score of 0? Yeah, snake in my boot. Some good old Tom Hanks right here. How much area is above a z-score of 0? Like, I know that this right here is 34% because it's half of 68. But I want to know how much is above a z-score of 0. What percent of area is above a z-score of 0? Because if I just take these two numbers and add them together, 50% exactly. So if you add these two numbers together, the 34% and the 50%, you will obtain the 84. And that's just one way of doing it. There's many, many, many ways of doing this, adding them all up. But this right here, just ignore the 68 then, because we're just using that to find 34% between -1 and 0. So good practice right there. A little tricky of a question. but good practice. 2 more questions to go. Last one's an easy one. Get ready for one more difficult one. Here we go. So this one's the easy one. 68, 95. What? You got this. You got this. You maybe heard me say it about 3 or 4 times. These are numbers you should have memorized. It doesn't hurt to memorize the 0.15, 2.35, 13.5, 34. Those numbers then repeat going backwards. 68, 95. And then the last number we need to know should be what? 99.7 exactly. And these are the numbers in the empirical rule Andrew was posting earlier, that this is the area between 1, 2, and 3 standard deviations. So you would say, I expect 99.7% of observations be between -3 and +3 z-scores. Excellent work right here. Let's find out the next question. Let's find out who the winner is. Here we go. It's going to be a close game. The coffee shop I am at is closing. If I leave now, do I still get the points earned? You do. We can do the last question right here. Let's do it real quick right here. Let's do the last question. You still get your points. Let's find out. Here's the last one. True or false? Predicting index of 30 for either company would be an extrapolation for this model. What is an extrapolation? And we're predicting at 30. This only goes up to 23. So what is an extrapolation? Last question right here. We're predicting over here at 30. Last question. I'll review it real quick. What's an extrapolation? When are we extrapolating? Correct. Sorry, the graphics are a little bit smaller. They changed something on Kahoot. Who knows when we are extrapolating? When we are outside the what? And why did Brian highlight a certain letter? When are we extrapolating on our model? When are we extrapolating? Because it says predicting at 30 would be an extrapolation of this model. So when are we extrapolating? When we are outside the what? Andrew's saying beyond in the future, I think so. The x-axis, Hannah's pointing out. Great job, Hannah, right there. We are extrapolating when we make predictions on our model for values outside the bounds of the x variable. Hence, extrapolation. So it's very true that if you were predicting up here at 30 or so, you would be doing an extrapolation of this current model. It is when you use the model to find y values of an x that is not in the original graph. Correct, or outside the bounds. Sometimes our x might have a certain scope to it, like maybe we're predicting people's heights and we have weights between like 100 to 300, and then we don't have a weight of like somebody who weighs 260, but we've got variables around that or like values around that. So we oftentimes say outside the scope of the x. Scope just means like the range of the x. So I should just maybe say that when we predict outside the range of the x's. So if we are predicting somebody's height when they have a weight of like 500, we'd be extrapolating from our current model. We could also extrapolate when it's below the min 2. So we could say our model would be extrapolating to predict the height of somebody who's like a kindergartner who maybe weighs like 60 pounds. So if we're going to predict the height of a kindergartner, our model's not really suited for that. It'd be extrapolating, going outside the bounds of the x variable. So an extrapolation is when you're outside the bounds of the x variable. You're predicting on x's your model doesn't really know. Who won? Let's find out with our special guest host who's always here.
Tiny Brian. Here we go, buddy. We got 3rd place. Great job. Fast Cheetah. I remember them. We got right here, Amiable Emu. Oh, I know who this is going to be. It, of course, is going to be Glowing Zebra. Great job, Glowing Zebra and Amiable Emu. Zany Wolf and Great Turtle. Hey, Great Turtle is still here. Woo! Tiny Brian, woo!
Tiny Brian just shows up at random times.
Where's my tiny puppet shark? Thank you, tiny puppet shark.
Where's my regular puppet shark? 3rd place, not bad. Ivan, great work. Great practice of your tool and knowledge. You almost placed right there. So great work. Good practice. Glad to see you still got that tool and knowledge. Good practice. And Glowing Zebra, Amiable Emu. Does anyone want to say who they were? Like if you're like, it helps me know if you're going to email me. Pop in randomly. wait. Just practice. Are you want to... I was email. Are you saying like on stream, Andrew? Do you want to say hey on stream on Discord? If you message me on Discord, I can pop you on stream for a second if you want. You love this? That was awesome. So glad, Alexis. Great work. But I hate emus. Tiny Andrew. I have to set some stuff up to pop you in on stream. If you want to say hey to everybody and encourage them for the test, I can take a Discord call from you. And so if you want, we can jump to the Discord really quick. Or if you want to be like, hey, good luck, everybody. Good luck. Yo, do another time, anytime. Mary, glad you had fun. Glad everyone had a lot of fun tonight. It's a lot of practice. Please email me if you have questions. This is just like a mini review with Tiny Brian and everyone. But glad we had TH was Emu. Was it Emu came in third or second or first? But yeah, just message me. Just to be clear, the test closes at midnight on Thursday. Very correct. Make sure if you have any problems, message me soon. Probably don't wait till like 10:30 to take it. Try to take it a little bit earlier, like set it up at a time that works for you. Anytime, Andrew, anytime. Just be like, hey, Brian, can I hop on to give some words of cheer? I'm also trying to set something up for the start of semester, like an event or stuff, so we can have like some people swing by and have some fun. But the test closes at midnight, Kendall. Great question right there. Any other questions? Definitely great practice for test. Exactly. I try to throw in as many extra little bits as I can. Little bits. Everyone knows we're going to play that right there whenever we say little bits. So we're playing our happy, sad music. Just chill out music. Let's go back to the main screen here. Let's do this. I'm back over here on the main screen. Excellent work, everybody. Please ask any question if you have it. Kendall, do you mind to review question 11? Sure, what was question 11? Let me go take a look at that. Which one was question 11 on this, right, Hannah? Let me go back and look at that. View full report. Have you stopped sharing your screen? No. I have. I don't know why it's like... Let me go look at it. I do not know what's going on. You're welcome, Kamara. You're welcome very much. Thank you. All right, let me go. I'm trying to figure this out. I don't know how things work. Let me go get question 11 up on the screen. What was question 11 about again? You might have to remind me what question 11 was about. Sorry, I'm logging back in. It like logged me out. Exam 1. Here's question 11. What is the best measure of center? Was it the best measure of center question? Here we go. It's so weird how you edit this. It's the one with which form of data is best used for the... So it's the best measure of center, right? See, look, my graphics are going to be way bigger. What? Look, I don't get it. I don't get it. This is how big the graphics should be, and this is not how big they are right now. I don't know what's going on. Kahoot, what you doing to me? They must have changed some sort of setting. I don't know if it'll change back, but yeah, that's not how big our graphics were. So just so you can see, that's how big they were. When you're looking at like the little tiny graphics on the screen, nope, big graphics. If you think I cheated and changed all these around, nope, they're big normal size graphics. I don't think I was quick enough to get all these changed. Normal size graphics. So whenever we're talking about the center of a distribution, what are the only two options for center? What are the only two options for the center of a distribution? The only two possible things you could choose for the center would be the what or the what. The only two options you could choose for center would be the what or the what. So the only two things we would choose for the center would be the what? The mean or the median. Now we're going to choose the median right here because it's very skewed. So you always look at the shape of the distribution to denote which way we're going to go with the center and the spread. So then if I change this to, we could just change it right now. What is the best measure of spread for the distribution? We'll change it for next time we do it. Now the best measure of spread for the distribution is the IQR. So I started a new hobby and it's lockpicking. A lot of good YouTube videos on that. Like there's a lot of people who do that as a hobby, especially if you're a magician. That's really good right there. So now the best measure of spread is going to be the IQR, and that's because it's skewed, because this is not going to be impacted by the skew. Does that make sense right here, Hannah? Great questions. Let me know if you have more. I think that should make sense here. We'll save this. Done. Awesome. Keep asking those questions. Any last questions in here? What questions do you have? Let me know which questions you have. We'll review any other questions. Put on a little chill music right here. Want this? Be practicing, be going over the practice test. Let's put the practice test in the chat one more time. Practice test is in the chat. Practice review materials in the chat. Please let me know whenever you have questions. You can always swing by office hours. Lately, been a lot of 320 office hours, which is totally fine. I'm just always wanting to help out 201. All you have to do is swing by and just say, hey, Brian, I'm working on this problem. Doesn't make sense. Let me know. There's a lot of Tool 1 help videos too. If you're looking through the YouTube channel, you can find a video on mostly anything, or old office hours videos. Anything about the 6895, 99.7? Are you wondering about TH, something about that specifically? Are you wondering about, what would you like to know about that? Definitely know the empirical rule, know how to use it, know how to find areas under the normal curve like we were doing tonight. And what specifically are you wondering? There's one question I really like on the, let me go to Mubot's link he just posted. So the link we posted, here, I'll put it on the main screen. So if you go down here to the link, you can watch speedrun videos, which you've probably seen some of those because you're in the asynchronous class. You can also watch practice questions, and I've posted some of those too for you to watch, like through the modules. When you go right here to the normal curve question, a lot of times people ask, well, how can you quiz us when we don't have the applet? And right here we go. This is a really great question, which says someone has a z-score of negative 0.55. I'm not thinking about when it comes to percentiles and percentages. So think about the first thing you want to do is you always want to draw a graphic for this. So whenever you get a z-score of like negative 0.55, you want to go in here and you want to draw a z-score. So let's just take a moment right here. We should see it on the screen in a moment, and draw where the z-score is going to be at. So let's just draw this out. We know the z-score, which means they'd be 0.55 below the mean. So they're going to fall right here. You can just see down here on the bottom of the screen, the z-score would be here. This is where negative 0.55 is at. So since they're at negative 0.55, how could we figure out which of these areas apply? At this point, we might have a good logical guess, but we can narrow it down a little bit further. We know that above 0, should show that here in a moment, we know above 0 is going to be 50%, because that's just half the curve. So above 0 is 50%. But what else do we know? We know that between, and this is what we want to look for, we want to look at this area above here, which is more than 50%. That narrows it down to 71 or 97.5. But from negative 1 over is going to be half of 68. So we need to break 68 down into 1/2, which is the 68 right here. We break that into 1/2. So that gives us 34, and then we add that to the 50. So from there over is 84%. So the answer has to be between 50 and 84%. It can't be as high as 84% because that'd be too much. And it can't be as low as 50% because that'd be too little. And that makes that the only answer. I think this is a really great question where we don't use the David M. Lane applet to like do the empirical rule. And I highly encourage, these are the practice test questions. And I do a lot of like walkthrough examples. You can also hear me kind of interpreting and walking through the test right here, kind of doing a full review. I'm just looking at myself. Was this recorded? My God, that's 4 years ago. 35 in that. I don't know about that hairstyle, Brian. I think I was recording that via Zoom also. Yup. Classic Zoom right there. So I think there's some really good help right here, especially just going through, and there's lots of like, here's the 6895. So if you want to go to review video on the 6895, 99.7, I still have this hoodie, I swear. Going through and plotting it out, check it out on how to do this. Number 5. Oh, which one? Number 5? Where? Were you wondering about something with number 5 related? Do you have another question, TH? Oh, number 5 on the practice test. Number 5, is it number 5 on the practice test? So if you go to the practice exam, is that the one you're talking about? Number 5, number 5, number 5, number 5. A particular cell phone company has a battery, is it 5.2? Or this one right here? So what percent of the batteries are expected to last 2 years or more under normal conditions between this and this percent? So we know that it has, here we go, let's go grab this. We'll go do this one real quick. Okay. And so calculate the z-score. I think you got that one. I would assume you got the z-score one. When we mark this right here, we're going to mark the mean and the standard deviation. So they have an average of this, which is the mean, and they have a standard deviation of this, which is the sigma. It also says that they're normally distributed somewhere right here. They follow an approximate normal, which means normally distributed. So now we want to go down here and we want to mark our graphic. So we are going to draw the normal curve. and we are going to give it the mean of 2.5. And then when we go down units right here, we're going to go down by 0.32. So 0.32, I might have misstated that a second ago, but that's the standard deviation marked up there. So if you subtract, you'll get 2.18, and that is the first standard deviation. And then down here next, I'll double check my math, you get 1.86. So Codename Kids, oh yeah, heck yeah, Codenames Kids Next Door. I watch that. It's a good Cartoon Network show right there. So that is right there. So what it's saying is we are trying to find out the area above above 2 right down here, which we know that this value has a z-score somewhere in here because we're looking for this right here. So it wants this area right here for us to know the answer for. Here's the area we want. But let me ask you this. Are you ready? How much area is from here over? How much area is from the center of the curve over? How much area is from the center of the curve over? From the center of the curve over is how much area? 50%. You got that right there. Boom. How much area is between here and here? So I've got a new mark on the graph right now. How much area is between there and there? That's a trickier one to get. Remember, this is between, you could kind of cut it in half and do between -1 and 1 to make a symmetric portion to figure out that area right there. I hate it when it does that. But how much area is this new one right in here? 34, because that's half of 68. Because if you do between here and here, it'd be 68 total, and we're doing half of it. Does that make sense right there, TH? How I'm getting 34? 80, and so 84 is the total. But do you understand how we're getting that there would be 34 right here? It's half of 68, because if you go 68 right here, then you can take half of 68, and you get the 34 right here. Awesome. Now, and great work, the Kahoot. I'm glad it's helping out. How much, this is a tougher one, and this one might not look so accurate. How much area is between here and here? This is a tougher one. It's one of the ones you can memorize. But how much area is between there and there? I can try to break it down. And yep, awesome. Between here and here is 13.5. Now, a few ways to get this. Probably, great job, TH, right there. 13.5 exactly. You could take, and remember we did 47.5 is what is across here. So if you know 47.5, which is half of 95, then you would get that value right there. Does that make sense? You got it. It's 13.5 because you're just subtracting, because you know 34 plus this has to equal this. That's half of 95 right there. So here's where these numbers come into play. I'm just going to erase the helper numbers. Would you agree with me that if I showed you this, this is too little area shaded? Like if I shaded from here over, this is too little. We want to go from here over. How much area have I shaded on the curve right now if I'm saying from here over? I've shaded 84%. How much area have I shaded on the curve if I shade from here over? Now I've shaded 90, my brain's breaking, 84, 97.5%. So what do you think we are trying to find? Let's take a look. This arrow, which I'll mark in, let's go purple right here. This arrow is too little, and it is 84%. And this arrow would be too much, like if I shaded from there over. And that's 97.5%. Another way to find that one is just to say 2.5 would be below that. So the answer should be, it needs to be more than 84, but less than 97.5. Is that making sense right here? Does this one hopefully make more sense? It's a tricky problem. I've solved it a few other times in some other videos, but is this making sense how the answers are going to be 84 and 97.5? So we'd get here, it's between 84% and 97.5. Does that make more sense, TH, right there? I'm hoping you see how the last, tell me if it doesn't, or I can go into greater detail. Oh my gosh, thank you so much. I appreciate that. I appreciate that a lot. It's a lot of practice. Hop on any of the streams. If you see me online, yeah, just be like, hey Brian, this problem doesn't make sense. It's a lot to be able to teach yourself, and Good. Everyone's working really hard, and I appreciate that so much. Because asynchronous classes are a little different than, live classes. A little different. A little tougher. Well, with that, I'm gonna head off. I'm gonna go eat some dinner. I'll see everyone later. We'll be back. Feel free to drop by any stream. I'll see you later, everyone. Bye for now. Bye. Do you still have the breakdown of the normal district curve that shows? Yep. Oh, we definitely got that. No, don't worry. I've got that in the help stuff on their asynchronous class.